Hello children, welcome to Wondercome. In this video, I will explain stoichiometry, which is the most important aspect in chemical equation. So, once you understand the concept, it will be very easy for you to solve all types of problem related to chemical equation. So let's start. So the literary meaning of the stoichiometry is the measurement of elements. Measurement or measuring the elements. Measuring or the measurement of the elements. And in fact, the stoichiometry represents the quantitative relationship between the reactants and the products in a balanced chemical equation. And the relationship may be in terms of your masses or volumes or molecules or even moles. So let's have an example to understand more about this. Let us consider a simple example of hydrogen chlorine, which gives hydrogen chloride. Let us balance this. So now this is a balanced chemical equations, and we have to, so this is 2, I am writing the atomic masses, and this is 35.5 and 2 chlorines are there, so I just multiply this, so this becomes 71, and this is your 1 plus 35.5, and this becomes your 73. So this 2 parts by mass of this hydrogen reacts with the 71 parts by mass of chlorine to give 73 parts by mass of hydrogen chloride. One should remember and keep this in mind that these numbers, this 2, 71 or 73 in these equations are only the proportions and not the actual masses of the reactants or the products. So we can consider any types of units such as either in kg or gram or even tons. If we are considering in case of masses, then we can consider any units, but the proportion remains same, as we can take 2 grams of hydrogen reacts with 71 grams of chlorine to give 73 grams of hydrogen chloride, or even 2 tons or 2 kg of this hydrogen reacts with 71 tons or kg of this chlorine to give 73 tons or 73 kg of your hydrogen chloride, in that way. So if this is in case of mass, if we are going to consider in volume, so 1 volume of hydrogen reacts with 1 volume of chlorine to give 2 volumes of hydrogen chloride. That we will discuss one by one. And moreover, this concept would help us to solve different types of problems. So let's discuss one by one. The first one we'll discuss is mass relationship. So we have to solve the problems based on mass and mass relationship. Very important aspects of this stoichiometry is to write the proper chemical equations, and you need to balance it properly. In this mass relationship, suppose mass of one reactant, one of the reactants has been given, then we can find out the mass of the products, or even we know the mass of the product, then the mass of the reactants can also be found out. Suppose we get calculate the mass of hydrogen chloride formed when 6 grams of your hydrogen is reacted with chlorine. So in that case, we have to first write down the equation, and that is that to balanced chemical equation, and we have to find out this mass proportion. Then we will write, so given mass is your 6 grams of hydrogen. So how much amount of what is the amount of hydrogen chloride is produced from 6 grams of hydrogen. So we have to, so in this mass relationship, so how we will write, so 2 kg, right, or 2 grams, sorry, 6 grams. So we'll write 2 grams of hydrogen gives 73 grams of hydrogen chloride. So given mass is 6 grams. So 6 grams of your hydrogen will give 73 by 2 into 6. So we will have 219 grams of your hydrogen chloride. So in this way we can find out if the mass of one reactant has been given, so we can find out the mass of the product by writing the balanced chemical equation. So one more similar type of problem, like calculate the mass of magnesium. I am writing in magnesium oxide formed when 2.4 kg of magnesium is heated in oxygen. Given the relative atomic mass of magnesium 24U and that of oxygen is equal to 16U. So we have to write down the chemical equation first. So magnesium oxygen will get magnesium oxide. We have to balance it. So this is our balanced chemical equation. So this is 48 and this is 16 plus 16, 32. This is 2 into 24 plus 16, which is coming around, coming to 80. So we need to find out the amount of magnesium oxide which is formed from 2.4 kgs of magnesium. So 48 kgs of magnesium will produce 80 kg of magnesium oxide. So 2.4 kg of magnesium will produce how much amount of your magnesium oxide, that can be calculated from this equation, isn't it? One more important problem, just we'll do that one. What amount of slaked lime? What amount, I'm writing in short, amount of slaked lime. Slaked lime is your calcium hydroxide, isn't it? Slaked lime will be obtained when 112 kg of quicklime, which is your calcium oxide, is treated with water. So we need to first write down the chemical equation. So calcium quicklime or calcium oxide plus, when it is reacted with water, it will give slaked lime or calcium hydroxide. So the reaction is a balanced one. So we have to find out this proportion. So calcium is 40 plus 16. This is your 56, and this is your 2 plus 16 or 18, and this is 40 plus 16 plus 1 into 2, which is your 74. So now you can find out. So quicklime, this much kg has been given. We have to find out the amount of calcium hydroxide that is produced. So 56 kg of calcium oxide will produce 74 kg of calcium hydroxide. So 112 kg of calcium oxide will produce how much amount of calcium hydroxide that you need to find out. So these are the problems based on your mass relationship on different equations or chemical equations. If you like this video, please press the like button. Send your comments and feedback. Thanks for watching this video.